Good evening, dear students. I welcome all of you for a demo class on surveying. Okay, myself, Professor H. Narendra Kumar from Civil Engineering program would like to give a demo class on fundamentals of surveying. Okay, you can see my name here, Professor H. Narendra Kumar, Civil Applied Program. I'm an academic tutor here. So today, I would like to take up a demo class on fundamentals of surveying. There are three levels in my presentation. So first I would like to start with level 1, that is basic questions. So let me read out the first question. The ruling principle of surveying. The ruling principle of surveying is to, there are 4 options given in the question: work from whole to part, work from part to whole, work from line to area, work from point to area. I think you are all having degree in civil engineering. So this question is not at all a difficult question for a civil engineering graduate. So there are 2 principles in our surveying. So I would like to show the answer slide also. So there are 2 principles of surveying. First principle is one of the most important principle in any surveying, that is work from whole to part, so as to localize the error and prevent their accumulation. Okay, I will not go for the explanation. Okay, you are all familiar with this. And second principle, only for the information sake, locate a point by at least 2 measurements. Okay, why I am giving 2 principles here? For you to understand there are 2 principles, because you may get another question on this second principle. So that is why you need to remember the second principle also. Work from whole to part as per the options. Okay, let me take up the second question. So this is related to the errors in surveying. So systematic errors are those errors. So there are 4 options here, which cannot be recognized. Second option, whose effects are cumulative and can be eliminated. Third option. Fourth option is whose character is not understood. Okay, these are all the options. So let me take up the solution. Okay, answer B is the solution for this. Okay, I will go back to the question. Answer B says whose effects are cumulative and can be eliminated. So how to remember the answer? See, systematic error is also called as cumulative error. If you look at the answer, systematic error, the other name for systematic error is cumulative error. Okay, but I am also giving the information of other errors, compensating errors. They are also called as random errors. I think you are familiar with the errors. There are 2 types of errors. One is cumulative errors, that is systematic. Other one is compensating, random. They are also called as accidental error. Please do remember both the names. Okay, for example, cumulative errors, they are also called as systematic. Compensating errors are also called as accidental or random. So the third question is surveys which are carried out to depict mountains, rivers, water bodies, wooded areas, and other cultural details are known as. So this is a classification of survey. Okay, so that survey which are carried out to depict mountains, rivers, water bodies, wooded areas, and others. Okay, so there are 4 options given here: cadastral surveys, city surveys, topographical surveys, guide map survey. So you need to know actually a little bit of the classification also. Okay, cadastral survey deals with the boundaries. City survey is nothing but within the city, whatever the surveys that is being taken up. Topographical. Okay, what is the topographical? Okay, topo and graphia. These are all the two terminologies that are used actually in the topographical surveys. Okay, so that is nothing but getting actually the information about the ground features like mountains, rivers, water bodies, wooded areas, and so on and so forth. So here is the answer. Answer C, topographical surveys. Conducted to obtain data and to make a map indicating inequalities of land surface. So land is not flat, right? Land is uneven. So we need to get the inequalities on the land surface. So topographic survey is done to determine the natural features of a country. Scale ranges from 1:25,000 to 1:, something like 10 lakh. See, for example, if you look at actually a small area, it will be around 1:25,000. And if you take the greater area, then it will be 1:2,50,000, 1:5 lakh, or sometimes it goes up to 1:10 lakh also. So the range is too much for the topographical surveys. And one thing you need to understand that I am not only concentrating on the answer, but also I am giving more information for you so that you can also answer any questions related to that. Is it okay? Okay, you can actually place your answer in the meeting chat. My explanation, is it okay for you? You want some more explanation? Okay, thank you very much. Let me continue with the fourth question. For a well-conditioned triangle, no angle should be less than. So here, first of all, I need to actually understand what is well-conditioned triangle. Okay, in the sense of surveying. So well-conditioned triangle is nothing but in which the angles are not less than 30 degrees and not greater than 120 degrees. Those triangles are called as well-conditioned, right? There are two types of triangles as per the surveying: ill-conditioned, well-conditioned, based on the angles. So as I said earlier, once again I repeat, well-conditioned triangles are those triangles in which the angles are not less than 30 degrees and not greater than 120 degrees. This is the explanation for well-conditioned triangle. So you will get the answer here itself. Okay, let me go to the answer slide. So answer B, that is 30 degrees. As I said earlier, well-conditioned triangle. So that is being highlighted here. You can see 30 degrees to 120 degrees. So these angles, okay, forms a well-conditioned triangle. But the best angle is 56 degrees. I am giving additional information for you. 56 degrees for triangle, in which 56 degrees 14 minutes. Okay, so that is nothing but the best angle for a well-conditioned triangle. But an equilateral triangle is the most appropriate well-conditioned triangle. But you know, actually in our surveying, it's very difficult to frame a the equilateral triangle. So we always follow this 30 degrees to 120 degrees. So as per the question, so it says 4 options: 20, 30, 45, and 60. So angle should not be less than 30 degrees. Answer is B. Okay, next question. Which of the following survey is conducted in order to determine the boundaries of fields, states, houses? So that is why while giving the answer for topographical surveying, I also explained actually the meaning of cadastral. Okay, I don't know how many of you concentrating on my explanation. What is that cadastral? Okay, cadastral meaning, dictionary meaning of cadastral is nothing but boundary of a plan, boundary. Okay, in order to calculate the area of a given place, Okay, we need to first of all demarcate the boundary. So that is called as cadastral. Okay, cadastral surveying is the answer. Answer B. It is used to produce plans of property boundaries for legal purpose. For legal purpose. Okay, for example, if you are owning a 30-40 site or 40-60 site in Bangalore, see, boundaries are demarcated. Is it not? So that you can claim this is my property and it is being numbered. So all these things comes under cadastral surveying. Okay, boundary of any area. For example, for the states, between the states, Karnataka and Andhra Pradesh and Tamil Nadu, you can see the boundary. While crossing over, okay, in Anekal, okay, there is a boundary. You can see that board also. Okay, you are actually crossing over from Karnataka to Tamil Nadu. Okay, there will be some arrangements there so that you will get an area. Those boundaries are very essential between the states as well as between the countries. So these things comes under cadastral survey. Number 6, hydrographic surveys deal with the mapping of, so hydrographic, the name itself gives you an idea, it is related to water. Okay, so there are 4 options here: large water bodies, heavenly bodies, mountainous region, canal system. So I can easily choose the answer because hydro means water. Answer A. It is conducted on or near water bodies. Marine survey is also one of its type. Marine survey is part of the hydrographic survey. Sometimes we use hydrographic surveying or sometimes we use marine surveying. One and the same. Number 7, the survey in which the curvature of the earth is ignored is termed as I said earlier, I am dealing with the basic questions. Sometimes you feel, okay, there are simple questions. But let me tell you frankly, the similar kind of questions will appear in the examination, my dear students. Okay, if you concentrate on the subject, if you go through the basic itself, okay, it is more than sufficient. And if you go through actually some complex problems, then you are easily crack any of the KPSC examination. I will assure you. Okay, so this is a very simple curvature of the earth. If it is not taken into consideration, ignored. Okay, 4 options are there: geodetic survey, aerial survey, plane survey, geological survey. Anybody is giving me the answer? Don't look at actually the answer table. Okay, since curvature is not taken into consideration, could you please give me the answer in the chat box? See, there are 2 divisions of surveying. Okay, one is plane surveying, other one is geodetic surveying. Okay, so in one actually curvature of the earth is taken into consideration, in the other one it is ignored. So the answer is nothing but plane surveying. It is done for engineering projects used for smaller area. Okay, there are certain what we say actually criteria to consider plane surveying. Okay, small area means you need not have to actually go for geodetic surveying. Earth surface is assumed to be flat. Line joining 2 points is a straight line. It is less accurate because when you consider geodetic surveying, the area should be greater than 250 square kilometer. Okay, and also the triangles are not plane triangles; they are spherical triangles. So there are a lot of actually, and you need to actually look into spherical trigonometry. Okay, which are complex mathematics. I think those who studied actually this astronomy, they understand this spherical trigonometry and all those things. Okay, so plane survey is the answer. Next one, the general layout of a new colony or town showing roads, market, hospital, river, etc. is called, okay, general layout of a new colony or town showing roads, market, hospital, river, etc. Okay, I would like to go back to your engineering degree. You know that actually you conduct this extensive survey project. Most of the civil engineers during their 3rd year or final year, they conduct extensive survey project. Before going through the projects, okay, first they create the going through reconnaissance. Okay, they create a plan. What is that called as? I think you are all familiar with that, right? So the answer is nothing but index plan. So we need to create the index plan so that most of the time index plan is created not to scale, so that you will get an idea. General layout of the new colony or town showing roads, market, hospital and river, so that you will get an idea from where I can start my surveying. Okay, what are all the scales to be taken care of, and so on and so forth. Similarly, there are other types of plan. Site plan, okay, position of buildings with respect to setting of points. Site plan are drawn to say scale of 1:100. I think you will get actually all these things. If you look at your own the site plan, okay, you will get all the details. And on a scale of 1:500 for the plots above 500 meters square in size. Key plan shows primary architectural elements of each building by floor level, such as walls, door. Okay, so civil engineers will create key plan. Okay, scale not less than 1:10,000, so that you will get an idea about the architectural elements. Okay, so answer is index plan for this question. A survey station must be fixed with reference to a minimum dash permanent objects 2, 3, 4, 5. Already given you the answer, because that is why we created the answer slide also. Apart from actually the answer, we will give more information. You know that there are two principles of surveying. What is the first primary principle? Working from whole to part. What is the secondary principle? Okay, the answer is there here. So if you can able to remember, you can give me the answer. Could you please tell me the answer for this question? Yes, place the answer. Be fair. Yeah, correct. 2 permanent objects is mandatory. That is our second principle. A survey station must be fixed with reference to a minimum of 2 permanent objects. So I copied the same principle here. To work from whole to part, to locate a new station by at least 2 measurements. That is mandatory. See, the same question can be asked in 2 different ways. Okay, now the complexity increases because you need to remember a few things in order to answer this. So this question deals with 2 questions. One is called as assertion, second one is called as reason. Okay, they will give one such a type of question in the examination usually. So assertion says 1 nautical mile is 1.852 kilometer. Reason, it is length of 1 minute of arc of a meridian on Earth's surface. Okay, once again, let me repeat. The assertion says 1 nautical mile is 1.852 kilometer. And the reasoning behind that is length of 1 minute of arc of a meridian on Earth's surface. Okay, it is the length of 1 minute. Meridian is nothing but latitude. Okay, so there are options here. Select your answer according to the coding system given below. So let me read out. Both A and R are true, and R is the correct explanation of A. Second, both A and R are true, but R is not the correct explanation of A. A is true and R is false. A is false, but R is true. So first of all, we need to remember that 1 nautical mile is 1.852 kilometer. So this is my answer. Answer A. That is 1 nautical mile is 1.852 kilometer. That is 1,852 meter. So the first is true. And what is that nautical mile? Is a unit of length used in air, marine, space and navigation, also for the definition of territorial waters. And historically, it was defined as the meridian arc length corresponding to 1 minute, 1/60th of a degree of latitude. Here, meridian and latitude, one and the same. Okay, you got it? The meridian, longitude is different, it is latitude. So, 1 minute of latitude is equal to that value, 1.852 kilometer. So, answer A is correct one. Both A and R are true. R is the correct explanation for A. Okay, 11th. In geodetic surveying, sum of all the angles, degrees of a spherical triangle should not be greater than. Already given you the answer there. Okay, I said something. You need to concentrate. Okay, so can you give me the answer for this question? In geodetic surveying, there are two divisions: plane surveying, geodetic surveying. In plane surveying, plane triangle. In geodetic surveying, we consider spherical triangle. Okay, what about the sum of the angles in a spherical triangle? Given you the answer. Okay, if you remember, please place it here. See here, should not be greater than. That is why I said actually, read the question twice. Okay, read the question twice. It says should not be greater than. Should not be greater than. Okay, there is the sum of all the angles in a spherical triangle is in the range of 180 to 540. It should not be greater than 540. So it should not be greater than 540 means, which is the correct answer here, my dear students? Spherical triangle are used and sum of angles varies between 180 to 540. So 540. Okay. So that means to say answer is D. It should not be greater than 540. If it is says it should not be less than, see, question can be asked differently. It should not be less than means 180. It should not be greater than means 540. Okay, 180 to 540. That is the characteristics of the spherical triangle. Okay, next once again a simple question. A branch of surveying in which the horizontal and vertical distances of points are obtained by instrumental observations is known as. Simple question. Okay, without getting into the answer slide, I think you can able to give me the answer. Horizontal and vertical distances. In chain surveying, will I get vertical distances? No. Illumination. Plane table surveying, vertical distances? No. Hydrographic surveying, vertical distances? No. So only the tachymetric surveying, wherein a tachymeter is being used, right? A tachymeter is used so that I can determine both horizontal and vertical distances of points. Okay, answer is C. Tachymetric surveying is a branch of surveying in which horizontal and vertical distances are determined by taking angular observation with an instrument. Even though it is called as tachymetric surveying, okay, we are going to make use of the observations here, but along with instrument, okay, we are going to make use of what? The theodolite fitted with stadia crosshair. It's called as a tachymeter. Okay, leveling staff is used so that we can calculate, determine both horizontal and vertical distances simultaneously. A surveying which is done to prepare detailed drawings of projects involving roads, railways. Okay, once again I repeat, I said you need to read the question 2 times. A surveying which is done to prepare detailed drawings of projects involving roads, railways. So cadastral surveying, engineering surveying, geodetic surveying, topographical surveying. Easy for you to choose the answer because others are for different matter. So engineering survey deals with the design construction of new routes and railways, also used for route alignment. I think you are all familiar with that. Okay, now this question related to errors. Okay, I think when I went through the question papers of yester years, there will be at least one question on the errors. Okay, so I thought actually even the regular class, okay, given a lot of questions on the errors. So usually you will get one question on errors. So what it says, the errors in measured length due to bad ranging. Bad ranging. Ranging, I think everybody knows. What is ranging? There's nothing but fixing intermediate station points, okay, along a straight line. Direct ranging and indirect ranging, you're all familiar with that. So if the ranging is bad, okay, what are the errors that you will get it? Observation error, or compensating error, or cumulative error, or both compensating and cumulative error. So you need to understand that if the ranging is bad, it is a cumulative error. Okay. So what is a cumulative error? What we learned actually in the first or second the question, cumulative errors are nothing but systematic errors. Okay. So the cumulative error are those which occur in the same direction. So if it is bad ranging, automatically the errors will accumulate in single direction. So that is why bad ranging comes under cumulative error. Tend to add up or accumulate. That is why it is called as cumulative. Whereas compensating error, I am giving you some more information. It is the difference between a measured value of a quantity and its true value. Okay, there are several. What is true value? Once again, I can go on explaining all these things. I need more time. Okay, let us stick on to the answer. I am giving some more information along with the answer. Observational errors, difference between a measured value of a quantity and its true value. Okay, level 2, conceptual. So we completed basics. Okay, let me take up conceptual. Slightly a different type of questions. So expectation is you need to know actually all the answers. And here, what is more important is it looks to be all the answers are correct, but you need to at least eliminate one of the answer. Sometimes maybe all the 4 answers are correct. Okay, that is also there. So you must actually work out. Without working out, closing your eyes, putting actually tick mark on one of the answer will not get us actually the correct picture. You need to solve this. This is something like a problem. So complete solution is there actually in my next slide. Let me read out the question first. Which of the following figures are equal to 1 acre? Okay, the question is very simple. There are 4 options here, equal to 1 acre. So first answer is 43,560 square feet. Second one is 40 guntas. Third is 10 square guntas chain. Fourth is 4850 square yards. Here there are 4 options. So we need to choose or select correct answer. So it says 1, 2, 3, 2, 3, 4, 1, 2, 4, 1, 3, 4. So first of all, we need to actually solve that. What is that 1 acre is all about? So I need to know a lot of information about not the basic surveying, but basic units in surveying. So you are all familiar with the SI units, but here we need to understand even the FPS system and the MKS system. Okay, the detailed answer is there in my answer slide. So A is the correct answer. That is 1, 2, 3. That is 43560 square feet, 40 guntas, 10 square guntas chain. Here, let me tell you, 40 guntas, everybody knows. Okay, in our state, 40 guntas is equal to 1 acre. So straight away, I will get the answer. And 1 acre, that is why I given you actually the first. 1 acre is equal to 40 guntas. It is a straight answer. Once again, don't go for other calculation. 1 gunta is nothing but 33 multiplied by 33. Okay, into 40. You can work out. That is how you need to work out. Everything you need to remember. Okay. And also, 1 acre is equal to 10 into guntas chain. Okay. 10 into guntas chain square. That is another answer. Next one is 4840 square yard. Okay, I will go back. See, they given actually 4850. But the correct is 4840 square yard, because that is equal to 43,560 square feet. Let me tell you, all these are interrelated, because when you calculate 40 guntas, you need to know actually the value of each gunta. Each gunta is nothing but 33 multiplied by 33. 33 feet by 33. So you'll get some answer. Multiply by 40, you will get this answer. Okay, these two are interrelated. Once again, what is this guntas chain? Once again, this gunta is derived from guntas chain. Okay, the length of the guntas chain is 66 feet. If you keep actually guntas chain in L shape, 33 by 33. The area covered by this gunta chain is equal to 1 gunta. So multiply by 40 is nothing but 1 acre. You got it? So each units are interrelated here. 1 acre is equal to 40 guntas, and 40 guntas is equal to 43560 square feet, and that is equal to 10 into guntas chain square. Okay, so this is about the answer. So you need to select what? Answer A. But you need to work out. If you are familiar with all these things, then you can easily answer. Otherwise, you need to work out. Okay, that is why this is not a basic question. Usually, such a type of question will carry 2 marks in the examination. The correct order of stages of engineering surveys. So, as a civil engineer, you need to know actually the specific order, because there are different types of surveys that we conduct actually in any engineering survey. So, what is the order? A final thing is preliminary survey. Now, you are all familiar with a few terminologies here. Okay, there are 4 options given: preliminary survey, reconnaissance survey, map study, final location, and detailed surveys. Okay, there are 4 options given here: ABCD, DBCA, BACD, or CBAD. So I prepared actually an answer slide in which I am giving you the right order that we went through actually in engineering survey. What we say? Correct sequence of engineering survey. So the answer is D. If I go back to the question, it is CBAD. C is, first of all, any engineer, please listen to me, any engineer study the map before going to the site. Okay, that is called as map study. Then there will be a reconnaissance survey based on the map study. Then a preliminary surveys will be conducted using some elementary instrument, and finally final location and detailed survey will be conducted. This is the right sequence. Okay, in any engineering survey, this is the sequence that everybody has to follow. Level 3 is the numerical. Okay, now it is more interesting. I expect you to actually involve in this numerical. Okay, so chat box is open for all of you. 1 square feet is equal to dash square meter. So you need to actually know how to calculate this. This is the first problem. I will show you how the answer will be. First of all, this you should know the first line that is being highlighted. C is the answer, that's okay. But first, this highlighted thing you need to know. Without that, it's not possible for you to get this answer. Okay, 1 meter is equal to 3.28. So even if you don't know this particular value, you can somehow manage. Okay, 3.8. Please remember all these units of measurement. If you go through any textbook on surveying, the first chapter or before the first introduction chapter, there are few pages dedicated for units of measurements. Unfortunately, teachers will not give much importance for these units of measurement. Straight away, they will introduce you to the basic surveying. But first of all, okay, you are familiar with that. But we need to actually first go through the units of measurements in different units, because each and everything is very important for a civil engineer. Whatever we learn actually in the classroom, okay, may not be applicable in the field, because we talk about acre, we talk about foot, 30 by 40 we see. Is it not? And sometimes actually 10 by 10 is the name of that is different in the field. So you need to remember all these information, then only you will become a very good civil engineer. So 1 meter is 3.28 foot. So what I am going to do is squaring the both sides. So 1 meter multiplied by 1 meter. So on the other side, 3.28 multiplied by 3.28. So I will get 1 meter square is equal to 10.7636 feet square. So I want actually 1 square feet. I will keep 1 square feet, and this goes to the denominator. This goes to the denominator. 1 meter square divided by 10.7636. So you will get the answer 0.0092905 meter square. Exact value. If you take only 3.28, you will get 0.092. Okay, that is also okay, no problem. Why I will tell you? Because if you look at the answer, okay, 0.092, you can easily take it. You don't require the exact value, okay, 3.2805, because you will be very near to the answer C, because these answers are 6.45, 6.54, 4.56 are all too large numbers. Okay, my dear students. So here, what we learned, the learning outcome of this question is 1 meter is equal to 3.28 foot. This you need to highlight. You need to make a note of it. I said in the previous class in PhD, you need to keep a notebook and a pen calculator. So highlight whatever we learned today. So based on that, we can able to calculate. See, if I know this, I can easily calculate this. I may not have to remember this answer. It's not required for me. Okay, 30 seconds is sufficient for me to get this answer if I know this units of measurement. Okay, which of the following figure is equal to 3 acre? This is a wonderful question. While solving this, I thought actually excellent question. Okay, but first of all, what we need to do while solving this type of question, we need to eliminate. But we need to remember a few things here. 3 acre is there. So the first answer is 2.1 hectare. What is 1 hectare? Approximately, not exactly, once again I said, approximately it is 2.5 acres. So 2.1 is nothing but greater than 3 acres. So directly I can eliminate this. 2.1 hectare is not the correct answer. Straight away I can give the reason. B, maybe. I need to work out. So 4.6875 square mile. I don't think so that will be the answer, because 3 acre will not create a square mile of 4.68. Not possible, right? And 4780 square yard. I don't know. I need to work out. So like that, you need to, otherwise you need to actually calculate each and everything, A, B, C, D for 3 acre. You will get 2.1. See, time consuming. If I can able to identify directly, eliminate it, right? So that is how I worked out actually the problem here. So answer B is the correct answer. See, 130,680. So how to get it? 1 acre is equal to 4046.856 square meter. These are all the things we need to remember, right? So that is nothing but 4046.856 multiplied by 10.76 square feet. We know already, we learned actually in the previous problem. 1 square meter is equal to 10.76 square feet. This you need to remember. Nobody is going to give you any information in the examination. This is what I said, units of measurement. So that is, if you multiply these two, you will get 43,544.17 square feet. Even you can actually leave this 0.7 here, no problem. So 1 acre is equal to so many square feet. So 3 acre means 43,544 multiplied by 3, you will get 130,632.511 square feet. So I got the answer for this. But other things that I need to check, 1 square yard. Okay, I will work out, because fourth answer may be right, I don't know. 1 square yard is equal to 9 square feet. Okay, so this yard and all those things are FPS system, but I need to remember. So 1 square feet is equal to 144 square inches. So 1 hectare is nothing but 2.471 acres. So it will not work out. So the correct answer is only the second one. All other answers are incorrect. Got it? So eliminate and find the correct answer. Sometimes if you eliminate correctly, then you will get the answer without working out also. Next one. Which of the following scale is the smallest one? Okay. Before getting into the answer slide, please listen to me. If there is any question on the scale, okay, MCQ question about the answers, First of all, the scale has to be converted into representative fraction. I think familiar with the terminology that representative. Elementary difference between a representative fraction and the scale, that you need to remember. Scale is nothing but we represent by 1 centimeter is equal to so many meters. This is called as scale. In the RF representative fraction, okay, there is no actually units given for that. It is 1 is to something. 5,000, 1 is to 50,000. So what I need to do is, already out of 4 answer, 1 is given in terms of representative fraction. The rest 3 I need to convert into. Okay, after the conversion of the 3 options into RF value, I can easily choose the smallest. I will tell you the reasoning also how to choose the smallest. Okay, let me take up the answer slide and also explain the conversion scale into RF. So here 4 is to 2 lakh is given. So that has to be converted into RF. So on the left hand side, okay, here you can see here. Okay, let me highlight. See, this 4 has to be converted into 1. So what to do? If that becomes 1, so I need to divide the right hand side 2 lakh by 4. So it becomes 1 is to 50,000. 2 lakh divided by 4 is 50,000. So I converted scale into RF. Next one is 1 centimeter is equal to 5,000 meter. Okay. So I need to convert it to 1 is to something. I will keep 1 here. So I will convert this 5,000 into centimeter. Meter is the centimeter. So 1 meter is equal to 100 centimeter. So 5,000 into 100. So it becomes 5 lakh. So I converted 1 centimeter is equal to 5,000 meter into RF value. Next one. 1 centimeter is equal to 50 meter. Once again, I need to convert this meter into centimeter in order to convert into RF. 50 multiplied by 100, it becomes 5,000. So RF is calculated. The fourth is already in the representative fraction. 1 is to 50,000. So 1 is to 50,000. Now it says the lowest value. I will go back to the question slide. What the question says, smallest one. So how to choose the smallest one out of RF value? How to choose the smallest one? See, wherever actually the right hand side of the representative fraction is maximum, okay, we say that is the lowest scale. Scale is very less. Okay, because it is 1 is to 5 lakh. What do you mean by 1 is to 5 lakh? 1 unit on the drawing is equal to 5 lakh unit on the ground. So we say scale is very small. Is it not? So here, after that, don't try to commit any mistake. Oh, 5,000 is less. So let me choose 5,000. It is not so. The highest value on the right hand side gives us the lowest scale. Please do remember this. Next one. The length and breadth of a field of area 33,600 meters square on map is 12 centimeter and 7 centimeter respectively. So length is 12 centimeter, breadth is 7 centimeter. This is on map. So you will get an area of 33,600 meters square. First we need to understand the problem. Read slowly. RF of the scale will be, I need to calculate the RF value for this. So two things I need to remember here. Area is 33,600 meters square field area, whereas on the map, okay, 12 centimeter by 7 centimeter is the measured value. What is the RF for this? So for this also I created a detailed answer. So area of field on ground 33,000. These are the data. First of all, I need to record the data. 33,600 meters square. Okay. Area of field on map. It is given 12 centimeter length, 7 centimeter Great. So if I multiply this, 84 centimeters square. So if I convert it to meter square, it becomes 0.0084 meter square. Okay. So I can easily calculate the area now. So what is the equivalent area? So 7 multiplied by 12, that is centimeter into centimeter, is equal to 33,600 meter square. So 1 centimeter square. So this 84 goes to the denominator. 33,600 divided by 84 is nothing but, if you do it, actually you get the answer 400 meter square. So now if I take the square root, so once this is nothing but 1 centimeter square is 1 square centimeter square. Okay, this I can write as 1 square, see the board, 1 square centimeter square is equal to 20 square meter square. Okay, so I can rewrite this as 1 centimeter is equal to 20 meter. Okay, so here units are different, centimeter and meter. So I can rewrite this as 1 centimeter. So 20 meter, if it is converted into centimeter, it is 2000. 20 into 100, 2000 centimeter. So if I cancel this, because on one is 2000. Okay, my dear students, this is how we work out. So based on the requirement, what the requirement of the problem? In the problem, it is actually in the RF value. The answer is D. A little bit of working out is there here in order to get the answer. Okay. This is another question. A rectangular plot of 16 kilometers square in area is shown on a map by a similar rectangular area of 1 centimeter square. A rectangular plot is there, okay, in the field 16 kilometers square. That is the rectangular plot area shown on a map by similar rectangular area, that is 1 centimeter square. That is 1 centimeter by 1 centimeter. RF of the scale to measure a distance of 40 kilometer will be. See here, let me tell you, this value is given to divert your attention to somewhere. Okay, this 40 kilometer is nothing to do with our calculation. Okay, they are asking us to calculate RF of the scale. RF of the scale that is used actually in this particular plan. That's all. Okay, 40 kilometer is no longer valid for us in our calculation. It's not required. What is the RF of? See, simply they are giving some false information in the problem in order to divert our attention, in order to confuse us. That is why it is nothing but conceptual, confusing type of questions. Okay, so you can easily sort it out because it is a straightforward question. So RF is equal to 1 centimeter square, that is on the plan, divided by 16 kilometer square, that is taken care of here. So it becomes 1 by 4 lakhs. That is the RF value. Okay, so easy for you to calculate. You got it? So very simple. Or otherwise you can also do like this. See here, all of you, I can make it, for example, if you can't able to understand whatever the answers like, so I will do it here. See here, 1, I will make it as simple as possible for you. 1 square centimeter square is equal to 16 kilometer square. Okay, they said rectangular plot. Okay, I'm not at all bothered about actually the shape of the plot also. I am bothered about actually the value 16 kilometer square. So what I'm going to do is 1 square centimeter square is equal to, this can be written as 4 square, right? I can write 4 square kilometer square. Okay, so 1 centimeter is equal to 4 kilometer. So 1 centimeter, if I would like to convert this into RF, so kilometer is to be converted into centimeter. How? 4 multiplied by kilometer into meter, 1000 meter, meter into centimeter, 100. So how many zeros are there? Please count. It is 4, 1, 2, 3, 4, 5. 4 lakh. Is it the answer? So there are different ways of solving the problem. And you have actually the direct answer, but you can also do it actually. See, without knowing anything about the problem, by observing this, you can able to calculate the right answer. Okay, see, most of the time, this is my observation because I'm having around 33 years of teaching experience. Always students commit mistake in the scale problems. Okay, a little bit of mathematics and common sense is required in order to solve this. All the scale problems are very simple problems. Okay, next question. A plan of an area drawn with the original scale. Okay, this is the problem related to shrunk scale. My expectation is, I think you're all familiar with the shrinkage ratio or shrinkage factor and the shrunk scale. Okay, so that is why if you are not comfortable, my answer slide will give you all the information about the relationships. Don't worry too much about it. So first, let me read out the problem statement. A plan of an area drawn with the original scale of 1 centimeter is equal to 10 meter. This is the original scale. Has a shrunk such that a line originally 15 centimeter long on the plan measures now 14.5 centimeter. You know that any material is shrunk automatically due to the environmental the factors. Okay, so the plan which is created long back, now they opened up, and when they checked, 15 centimeter long on the plan now measures only 14.5 centimeter. So we need to calculate what the shrunk scale is given by 1 centimeter equal to what. So that is our responsibility to calculate the shrunk scale. So I created a detailed solution for that for you to understand. Okay, apart from I inserted some more information for you because I know actually most of you you don't know, maybe forgotten the equations or relationships. Okay, first of all, we'll rewrite the data. Little bit of working out is required in this problem. Original scale 1 centimeter is equal to 10 meter. It's given. Okay, representative factor 1 by 1000. So I am converting this. I think you are all familiar now. RF, you can stop me actually. You can place your comments. So please explain once again this. I don't mind in explaining. See, this is the original scale. 1 centimeter is equal to 10 meter. That is why it is called a scale. So if I convert this into RF, so what happens? This meter is to be converted into centimeter. 10 into 100, it becomes 1000. So RF value for this original scale is 1 by 1000. Now there is a formula. Shrinkage ratio, are also called as shrunk factor, is equal to shrunk length divided by original length. Okay, so in order to calculate actually that shrinkage ratio, some books they say shrinkage ratio, some books they say shrinkage factor, no problem. Okay, shrunk length 14.5. This is extracted from the problem statement 14.5. What was the original length? 15. So shrinkage factor is, okay, this is, it is a factor, it's a ratio. So this is not required centimeter. 14.5 divided by 15. right? This is the shrinkage ratio or shrunk factor. Now, what is shrunk scale? Because the question is calculate the shrunk scale. Shrunk scale is equal to shrinkage ratio multiplied by original scale. Same question, same equation is written differently. Okay, shrunk scale is equal to shrinkage ratio multiplied by original scale. Shrinkage ratio, just now we are written. So this is written here, 14.5 divided by 15 multiplied by, okay, original scale, the RF value 1 by 1000. So if I calculate using my calculator, I will get 1 by 1034. But in the answer slide, okay, in the question slide, I'm sorry, it is given in terms of scale. So here this is the RF value. So I need to convert into scale. So this becomes 1 centimeter is equal to, if I convert into meter, so it becomes 10.34 meter. So I need to search for this. Answer is C. It is there actually in the question slide. Okay, 10.3. Right. So you should know actually conversion of scale into RF and also the relationship between shrinkage ratio, shrunk length, and original length, and also shrunk scale. Make a note of all these things. Okay, if you are comfortable with these equations, any problem on the shrunk scale can be easily solved. Next one, 100. Okay, this is related to your theodolite. I think, yeah, still I remember in the Viva, we ask the same question. Okay, we say, first question is, what is the least count of theodolite? Everybody knows theodolite is having a least count of 20 seconds. Explain. So I don't think so I got the answer in my 33 years of service. 20 seconds. Everyone knows actually it is a 20-second theodolite. But how to get that 20 second? Answer is there in this question, my dear students. So this is nothing but a transited theodolite. Okay, whatever the theodolite that is being used in our measurement is called as transit theodolite. The other name for theodolite is called as transit. Okay, vernier transit theodolite. So the main plate of a transit is divided into 1080 equal divisions. So 1080 equal divisions. 60 divisions of the vernier coincide exactly with 59 divisions. Okay. 60 divisions of the vernier coincide exactly with 59 divisions of the main plate. This is the important observation that you should do with the theodolite. Okay. In vernier, there will be 60 divisions, but if you actually align with the main plate, okay, it exactly coincides with the 59 divisions. That is why we actually identify what is that coinciding division in the vernier. If it is 60, then all the divisions are coinciding. Is it not? If both are 60, then all the divisions are coinciding. So, but here there are only 59 divisions. So, what is the least count in seconds? Okay, for this also, answer is in detail. Let me explain. So, 360 by 180, 1080. Why 360? The complete circle is 360 degrees. Thereby, the question says it is divided into 1080 equal divisions. You can check it out. 1080 equal divisions. Multiply by 3600 divided by 60. Why 3600? Because 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. So 60 multiplied by 60, it becomes 3600 divided by 60. Because I am converting this into seconds, right? I am converting this into seconds. So if you calculate this, you'll get 20 seconds. This is the question they ask actually in the Viva examination. What is the least count of theodolite? 20 seconds. Explain how you are going to get 20 seconds. Because the coinciding divisions, okay, is only 59 there. 60 divisions are there in the vernier, but it coincides with only 59 divisions of the main scale. So that is why the least count is 20 seconds. One division, the value of one division is equal to 20 seconds. Okay, how to get This is the answer. Next question. The plan of a map was photocopied to a reduced size such that photocopied is nothing but Xerox. Okay, you know that reducing Xerox is also there. So when you go for reducing Xerox, okay, some changes are there actually in the plan of the map. So we need to revise the scale. Okay, let me read out. The plan of a map was photocopied to a reduced size such that a line originally 100 millimeter measures 90 millimeter. It was actually 100 millimeter originally, now measures only 90 millimeter. The original scale of the plan was 1:1000. Original scale is given. The revised scale, what is the revised scale? So once again, we need to work out the problem using this original scale as well as the shrinkage factor. So shrinkage factor is nothing but shrunk length by original length. So while doing the photocopying, they reduce this size. Sometimes we do, right? Sometimes we'll say a 70% reduction, 80% reduction. When you reduce actually, then we need to calculate the revised scale. Otherwise, whatever the measured distances are not correct. I need to apply this revised scale for that. Okay. So I need to calculate the revised scale. So shrinkage factor, first calculation is shrinkage factor. So it straight away gives me the value 90, 100. Okay. So 0.9 is the shrinkage factor or shrinkage ratio. So revised scale is equal to original scale multiplied by the shrinkage factor. This already explained in the previous problem. So original scale, it's given actually in the problem statement, 1/1000 multiplied by 0.9, that is shrinkage factor, 0.9. Same thing is substituted. So the answer will be 1/1111.11. So it is a straightforward problem. So we know the original scale, we know the shrinkage factor based on the reduction during the photocopy. So I can easily calculate the revised scale. Next is related to calculation of representative fraction. Okay. Now, without looking at the answer, you just have to give me the solution for this, because it's a very, very simple the question. If the scale is taken as 1 centimeter is equal to 50 meter, what is the representative fraction, RF? Once again, I am repeating. Usually in our engineering discipline, we say scale means it is some centimeter is equal to some meters, 1 centimeter. Units are there on either side. Then it is called as scale. When units are not there, 1:something, then it is called as representative fraction. So what is the requirement? These two must be of same unit. So if you convert it, then you will get the answer. Please do it and tell me the answer. And always in the representative fraction on the left hand side, 1 should be the value. On the other side, whatever it may be. So please give me the answer. Representative fraction. Here, one thing you need to understand, they're asking us actually not in terms of 1:something, they are asking actually the decimal system. Okay. I am expecting you to answer this question. Okay, somebody said D. Let me check. So here, how to, first of all, let me work out. See here, 1 centimeter is equal to 50 meter is there. How to convert into centimeter? Multiply by 100, 5000 centimeter. So these two will go. So I can write RF as 1:5000. So using my calculator, if I do 1:5000, I'll get the answer. That's all, right? Simple. So answer is there in the next slide. So 1/5000, I'll get 0.002. This is a straightforward question. Let me tell you, these are all the questions that are taken from previous question papers. Okay. So this is related to, once again, the scale. A surveyor measured the distance between 2 points on the plan drawn to a scale of 1 centimeter is equal to 40 meter. Okay. The result was 480 meter. Later, however, he discovered that he used a scale of 1 centimeter is to 20 centimeter. Okay. Whereas you just have to use actually 1 centimeter is equal to 40 meter, but unfortunately, it's a mistake. We used actually scale of 1 centimeter is equal to 20 meter. Find the true distance between the 2 points. Directly can give me the answer. Okay, because it is 480 meter. Used 1 centimeter is equal to 20 meter. If it is 1 centimeter is equal to 40 meter, the value of this, the result will get doubled. Very simple. Without solving the problem also, you can give me the answer. So 480 multiplied by 2 is nothing but 960 is the right answer. Okay, nobody expect you to give the solution for this MCQ. You need to show them the solution, how to get 960. Okay, some problems based on your general knowledge, you can straight away give the answer without even solving the problem. Looks to be a difficult problem, but when you look at the scale, it is being doubled, right? 1:20 and 1:40. Then it should be 960 instead of 480. But I need to work out, I need to show, right? Okay, distance between the points on the plan drawn to a scale of 1 centimeter is equal to 20 meter. Distance was 480. Data is simply copied. So 480 divided by 20 is 24. Okay, actual scale is used 1 centimeter is equal to 40 meter. They used actually 1 centimeter is equal to 40 meter. So true distance will be 40 multiplied by 24. It is 960. Got it? Got doubled because for using a wrong scale. So instead of wasting this time, directly you can also solve the problem. Possible. Okay, this is level 4 confusing type of questions. I highlighted actually even the answer in this question because the question itself is something confusing. So my advice is please take up these questions at the end of your session. Okay, don't waste your time in the beginning in order to solve these kind of questions. Okay, you keep actually this confusing, identify these questions and keep it as it is and come back after solving actually all those questions and you can able to do it. So there are 2 lists given here. The first list gives us actually different types of map: geographical map, topographical map, location map, forest map. Whereas on the right hand side under list 2 given us actually the scale 1 centimeter is equal to 2.5 kilometer, 1 centimeter is equal to 0.25 kilometer, 1 centimeter is equal to 160 kilometer, 1 centimeter is equal to 5 meter to 25 meter. Okay, so these are all the answers. Here, first of all, we need to identify the realistic values. Okay, what is that realistic values? Location map. Okay, location map usually we create for lesser scale. Okay, location maps. 1 centimeter is equal to 5 meter to 25 meter. So this is the correct answer. So when you look at the options, okay, C4 is there in 2 places. So either A is correct or B is correct. Now I need to look for the other one. The other one is nothing but the topographical map. Easy for me. Topographical map. Okay, I will look for the options. 1 centimeter is equal to 2.5 kilometer. 1 centimeter is 0.25 kilometer. 1 centimeter is 160 kilometer. Usually the topographic map that is created for 1 centimeter is equal to 2.5 5 kilometer. Okay, so this will be B1. There is a range. Here the problem is it is not exact. All the topographical map will not be in the same scale. 1 centimeter is 2.5, but that range is there, so that is why I modified that. Okay, so B1 is there and C4 is correct. So the B1 is here, C4 is here. Other things I will not worry about. So let me look at actually, because for my confidence, geographical map, it says A3. Okay, that is 1 centimeter is equal to 160 kilometer. Yes, geographical maps are for larger scale. Okay, and finally, the forest map, 1 centimeter is 0.25 kilometer. Let me tell you, yes, I know this is not possible for us to remember all these values because there is a range and also the scales are there. This is not even the RF value. And if you like to convert this into RF, then you are going to lose actually precious time. So this, once again, you need to identify 1 or 2 right answers and look for the choices and answer the correct one. Okay, so first, that is why I chosen actually the location map, because I can easily find the right answer for that. Next, I will go for some other the map in order to choose the right answer. So if 2 are correct, I can easily get the answers. That is why they are also very clever. 4 is here, 4 is here. They know actually when they identify this, okay, if 4 is not there, straight away I would have selected this. But 4 is here, I must be cautious now. Okay, the answer may be A or answer may be B. So this is nothing but elimination once again. So that is why it is taken as the questions and fusion. A few things. Next one is another confusing, but less confusing. List 1 gives us actually the source of error. List 2, type of error. So list 1, there are A, B, C, D, bad ranging, bad straighten of chain, careless working, non-horizontality. Okay, there are 4 sources of error. Type of error, cumulative, insignificance, compensating, positive. Different types of errors are listed here. So once again, I need to actually look for known answer form. Already I learned actually from today, bad ranging. Okay, so bad ranging, already got the information that it is a cumulative type of error. So I got the correct answer. So if you look at actually this, fortunately for me, okay, under this course, B1 is already there. Okay, so A, bad ranging, 1 is the answer. There is nowhere actually 1 is given here. So I can straight away pick it without wasting my time. Here, fortunately, the list 2 and list 1 are given actually straight away. B is insignificance. Bad straighten of chain is insignificance usually. Careless working, it is compensating, either plus or minus. Non-horizontally, this is nothing but a positive. You know that actually errors in surveying, if you look that non-horizontality in our survey, okay, gives us actually the positive values. But as I said earlier, I got the answer for the bad ranging already. I know this is cumulative. I can easily, without wasting, without looking into other list, other sources of error. Okay, my dear students. See, you must be very clever actually in answering confusing questions. Okay, instead of wasting actually more time on this, so if you get the right answer, take it. Don't worry about others, because here I am 100% sure or 200% sure that bad ranging is cumulative. So here one is already noted down. So it must be actually the B, the answer B, right? So answer is B, and some information for you, cumulative compensating for different cases. Okay, please go through it. Anyhow, it is already being shared with you. So go through it because you cannot expect similar kind of questions. We'll try to cover at most possible in our MCQ because the only one chapter giving you almost 28 questions, only the fundamentals. Okay, this is only fundamental. A lot of things are there in surveying to go through. Okay, thank you very much. My session is over. If there is any questions, you can place it in meeting chat, and also you can give me the feedback. Is this session is good or average, or if any improvement is required, feel free, because it is, once again, let me tell you, I should have informed you earlier, this is a demo class. Okay, so that any improvement required for further hybrid classes, it is very essential for us also to improve. There is always a scope for improvement in online classes. So please say yes, everything is okay, or any feedback, feel to give your feedback. Don't worry about your name and other things. Okay, we are always open in our mind. Okay, and we'll incorporate whatever the feedback that is given by you. If everything is okay with this session, please say okay with this session, so that we can wind up actually our class. Yeah, thank you very much for joining this demo class on fundamentals of survey. Thank you. Good day.